Okay, hello students. Our topic of discussion for today will be about volume of revolution of a surface bounded by two curves and the x-axis or the y-axis about the x-axis or about the y-axis. And at the end of this topic, you are expected to find the volume of revolution of a surface bounded by two curves about the x-axis or about the y-axis, and you are expected to derive formulas for volume of what we call cylinder, cone, frustum of a cone, and a sphere. Now first, let us try to see a revolution about the x-axis. Suppose you have given a region that is bounded by two curves, f and g, on the closed interval a comma b. Now, revolving this region about the x-axis will have such kind of solid figure. And the volume of this solid figure can be obtained by the formula pi, the integral of from a to b of the absolute value of f square x minus g square x dx. So this is the formula for volume of solid of revolution about the x-axis. When we come to volume of revolution about the y-axis, we'll have almost similar formula. It says volume equals pi integral from a to b, the absolute value of f square y minus g square y dy. And the difference between these two is that in the previous one, the revolution about the x-axis, the lower limit and the upper limits of integration a and b refers to the vertical lines x equals a and x equals b. But when we come to revolution about the y-axis, this a and b refer to the horizontal lines y equals a and y equals b. In the previous formula, we have f of x the whole square and g of x the whole square. That means in revolution about the x-axis, you are expected to express y in terms of x. But here it says f square y minus g square y. That means you are expected to express x in terms of y. So this is the difference between revolution about the x-axis and volume of revolution about the y-axis. Now let us see two examples. One about revolution about the x-axis and the other revolution about the y-axis. Example 1 says, find the volume of the solid generated when the region bounded by the lines y equals x and the horizontal line y equals 4 on the interval 1, 3. This region when it is revolved about the x-axis. As I have mentioned before, volume of revolution about the x-axis is given by the formula pi integral from a to b of the absolute value of f of x the whole square minus g of x the whole square dx. Now our f of x is, you can take x to be f of x and g to be 4. So you can take f of x to be x and g of x to be 4. Therefore, volume equals pi times integral from a to b. Our a and b are 1 and 3. From 1 to 3, the absolute value of f of x the whole square, that means x square minus g of x the whole square, 4 square dx. So we have the integral from 1 to 2 of the absolute value of x square minus 16 dx. Now here the question is, in the interval 1, 2, which one is greater? Is x square greater than 16 or 16 greater than x square? Good. Obviously, in the interval, that means for every x in the interval 1, 2, 16 is always greater than or equal to x square. Therefore, the absolute value of x square minus 16 will be 16 minus x square, because 16 is greater than or equal to x square. Then after it is a matter of evaluating this integral. The integral of 16 is 16x, that of x square is 1 over 3 x cubed. Evaluate this from 1 to 2. Then We have pi into 16. Our x is 2. I mean, it is not 2, rather it is 3. 3. This is 3. This is 3. Okay? So evaluate this from 1 to 3. We have 3 minus 1. Minus 1 over 3. 3 cube minus 1 cube. So you'll have pi times 16 times 2 is 32 minus, this is 27 minus 1, 26, 26 over 3. 3 times 32 is 96, 96 minus 26 is 70. So you'll have 70 over 3 pi. This is the volume of this solid figure. Okay? 70 over 3 pi. Let's pass to the second example. Find the volume of the solid generated when the region bounded by the graphs x equals 1 and x equals minus 1 over 5y plus 16 over 5 between the horizontal lines y equals 1 and y equals 6. This is volume of revolution about the y-axis. So our formula is volume equals pi times integral from a to b of f square y minus g square y or gy square dy. Now, what are my f of y and g of y? You can take one of them as f of y and the other g of y. Let f of y be 1 and g of y be minus 1 over 5y plus 16 over 5. So pi integral a and b are obviously 1 and 6. The absolute value of g of y square, 1 square minus negative 1 over 5y plus 16 over 5 the whole square dy. Pi integral from 1 to 6 of 1 minus negative 1 over 5y plus 16 over 5 the whole square dy. Now let us apply integration by substitution. Let u represent this expression. Okay? So from this, the derivative of u will be negative 1 over 5 dy, meaning dy is negative 5 du. So the volume will be pi times integral from a to b. When y is 1, negative 1 over 5 plus 16 over 5, 15 over 5, that is 3. And when y is 6, negative 6 over 5 plus 16 over 5, 10 over 5, which is 2. The absolute value of 1 minus, this is u square du, dy. But dy is negative 5 du. Negative 5 du. So, take negative 5 out, negative 5 pi, integral from 3 to 2 of the absolute value of this one du, or if you interchange the upper and lower limit of integration, we'll have negative 1, so you'll have 5 pi integral from 2 to 3 of the absolute value of this expression du, but in the interval 2, 3, u square is always greater than 1. So the absolute value of 1 minus u square will be u square minus 1 du. Then after, it is a matter of evaluating this definite integral. The integral of u square, this one, minus the integral of 1, you evaluate from this, from 2 to 3. 5 pi times 1 over 3, 5 pi over 3. So 3 cube minus 2 cube, 3 cube minus 2 cube, minus 5 pi times u, 5 pi, my u, 3 minus 2, that is 5 pi over 3, 27 minus 8, that is 19, minus, this is 1 times 5 pi, 5 pi, so I'll have 5 times 19, 95, 95 pi over 3 minus 5 pi, now 3 times 5 pi, 15 pi, 95 pi minus 15 pi, 80 pi. 80 pi over 3. This is the volume of the solid of revolution about the y-axis. Hello students, how are you doing? I hope you are busy of working on the materials that we have given through the Telegram channel of the school. Today we will have the first video lesson. After watching this video lesson, if you find it important, then we'll have other video lessons in the subsequent topics. Now, the first topic of discussion for today will be about volume of revolution. And at the end of this topic, you are expected to calculate volume of revolution of solid figures about the x-axis and the y-axis, and you are expected to solve real-life mathematical problems related to solid of revolution. Now, as I have mentioned before, the topic of discussion is volume of revolution. To start our discussion, let us consider a region that is bounded by the graph of a certain function f, the x-axis, and from the left and from the right by the two vertical lines x equals a and x equals b. Now, when we rotate this region about the x-axis, we'll have a solid figure of this form. Now, the question is, how can we find the volume of this solid figure? Now, to do this, first we have to partition this solid figure into slices. And one of these slices looks like this one. As the number of partitions becomes larger and larger in number, the thickness of this slice becomes thinner and thinner. Therefore, practically, this slice will be almost a cylinder. Okay? And as you know, the volume of a cylinder can be calculated by the formula pi r square times h. Now, for this tiny cylinder, the height is nothing but a very small portion of x, and we call it dx. And the radius is the functional value of f at x. So substituting this in place of r and h, we'll have volume of slice equals pi. Our r is f of x, so f of x is the whole square, and h is dx. Now, what is the volume of this solid figure? The volume of this solid figure is the integral sum of the volume of these slices. Therefore, the volume of the solid of revolution is given by the integral from a to b of pi f of x squared dx. If I take pi out of the integral, we'll have pi times the integral from a to b of f of x dx. This is the formula that enables us to find the volume of revolution of a surface about the x-axis. When we come to volume of revolution of a surface about the y-axis, the formula will be volume of solid of revolution about the y-axis equals pi times the integral from a to b of f of y the whole square dy. Now let us see the difference between these two formulas. I think they are almost similar in pattern, but the difference here is a and b are vertical lines, x equals a and x equals b. When we come to here, a and b are horizontal lines, y equals a, it refers to y equals a and y equals b. Here it says f of x, that means we are expected to write y in terms of x, but here it says f of y, meaning x has to be written as a function of y. And the variable of integration in the first one is dx. When we come to the second one, it will be dy. So using these two formulas, we can find the volume of revolution of a surface about the x-axis and about the y-axis. Now, based on this, let us have a series of examples that needs the application of these two formulas. The first worked example says, find the volume of the solid generated when the region bounded by the line y equals x and the x-axis on the interval 0, 3. This is the region. Now, if you revolve this region about the x-axis, we'll have a solid figure of this type. I think you know its name. What is it? Good. It is a cone. Now let us see how to calculate the volume of this cone using integral approach. Now, as I have mentioned before, volume of revolution about the x-axis is given by the formula pi integral from a to b of f of x the whole square dx. Our f of x is x. Now we'll have pi times integral from a to b. The lower limit of integration and the upper limit of integration are 0 and I think from 0 up to 3. F of x is x square dx. So I'll have pi times. Now what is the integral of x square? Good. It is 1 over 3 x cubed. Now we evaluate this function from 0 to 3. Now 1 over 3 is a constant, so we can take it out. So you'll have x cubed evaluated from 0 to 3. That means 3 cubed minus 0 cubed. 1 over 3 pi. 3 cubed is 27, minus 0 is 27, and 1/3 of 27 is 9. Therefore, the volume of the solid figure, or in our case, that cone is 9 pi cubic units. Okay, this is all about the solution of example 1. Now let us pass to example 2, worked example 2. It says find the volume of the solid generated when the region bounded by the curve y equals x square. This is the curve representing y equals x square, and the x-axis on the interval 0, 1. Now, when we rotate this region about the x-axis, we'll have such kind of solid figure. Again, our aim is to find the volume of this solid figure. Now let us see it. Question number 2. Volume of revolution about the x-axis is pi times the integral from a to b of f of x the whole square dx. Pi times the integral from a to b, in our case from 0 to 1, and f of x is given to be x square, so you'll have x square the whole square dx. Pi times the integral from 0 to 1 of x square the whole square is x power 4 dx. Now, what is the integral of x power 4? Good. I think it is 1 over 5 x power 5. Now let's evaluate this from 0 to 1. 1 over 5 pi is a constant, so you have 1 over 5 pi. Now let's evaluate x power 5 from 1 to 0. That is 1 power 5 minus 0 power 5. 1 over 5 pi times, I think the expression within the bracket is 1. And 1 over 5 pi times 1 is 1 over 5 pi. So this is the volume of that solid figure. Now let us pass to the third example. Okay, the solution of the first example looks like this one. This is in your slide, so you can refer it from the slides. Now work the example question number 3. Find the volume of solid of revolution when the region bounded by the curve y equals e power x minus 1 and the x-axis on the interval minus ln 2 rotated about the x-axis. Here is the graph of y equals e power x minus 1, and we take the region that is bounded by this graph and the x-axis on the interval minus ln 2. Now when we rotate this region about the x-axis, we'll have such a solid figure. Now again, let us see how to find the volume of this solid figure. Again, volume of revolution about the x-axis is pi integral from a to b f of x the whole square dx. Pi times, now the lower limits and the upper limits of integration are minus ln 2 and ln 2, and the function is e power x minus 1. So minus ln 2 to ln 2 e power x minus 1, this is our function, the whole square dx. Now the integral pi times the integral minus ln 2 using a relation in logarithm. Ln of negative ln of 2 is the same as ln of 2 power negative 1. 2 power negative 1 is 1 over 2. So I can write it as ln of 1 over 2. 2 ln 2. Now let us expand e power x minus 1 the whole square, and it becomes e power to x minus 2 times e power x plus 1 dx. Now let us take the integral of each part. The integral from ln of 1 over 2 to ln 2 of this expression. Okay, what is the integral of this one? There is no need of writing it. What is the integral of e power to x? I think it is 1 over 2 e power to x minus 2 times the integral of e power x is e power x itself, plus the integral of 1 dx is x. Then let's evaluate this from ln of 1 over 2 to ln 2. So pi times 1 over 2, let us take it out, and we'll have e the power of 2 times ln 2 to ln 2 minus e power 2 times ln of 1 over 2 minus 2 pi, then e power ln 2 minus e power ln 2 minus e power ln of 1 over 2, and then plus ln 2 minus ln of 1 over 2, ln 2 minus ln of 1 over 2, and that is 1 over 2 pi e power 2 ln 2 means ln 4 minus e power ln of 2 ln of 1 over 2 is ln of 1 over 2's whole square, that is ln of 1 over 4 minus 2 pi e power ln 2 is nothing but 2 minus e power ln of 1 over 2 is 1 over 2, okay, plus ln 2 minus ln of 1 over 2 is nothing but plus ln 2. So I have 1 over 2 pi, this is 4, minus e power ln of 1 over 4 is 1 over 4, minus 2 pi, we have here 2 minus 1 over 2 is 3 over 2, plus ln 2 plus ln 2 2 ln 2. And that is 1 over 2 pi. 4 minus 1 over 4, I think it is 15 over 4 minus 2 pi times 3 over 2. 2 cancel these 2, so you'll have 3 pi plus 2 ln 2. Now let us have this product, 15 over 8 pi minus 3 pi plus 2 ln 2. Now let us subtract 3 pi from this one. 15 minus 24, negative 9. Negative 9 over 8 pi plus 2 ln 2. I think there is pi here, okay? So we have write pi in this expression too. There is pi, okay? There is pi. Now if I take pi out as a common factor, we'll have 2 ln 2, 2 ln 2 minus 9 over 8. This will be the volume of that solid figure. Now let us see its solution. Good. 2 ln 2 minus 9 over 8 pi. Okay, let us pass to the fourth example, worked example. Find the volume of the solid obtained when the region bounded by the graph of y equals minus 3x plus 11. This is portion of the graph of y equals minus 3x plus 11. And the y-axis between the horizontal lines y equals to 2 and y equals 8. Now when we revolve this region about the y-axis, we'll have such kind of solid. Do you know the name of this solid? Good. It is called frustum of a cone. Now let us see how to find the volume of this frustum of a cone. Unlike that of example 1, 2 and 3, this is volume of revolution about the x-axis, whereas the y-axis, whereas the previous ones are revolutions about the x-axis. Now, as you know, formula for volume of revolution about the y-axis is given by the formula pi integral from a to b of g of y, the whole square, dy. Here it says g of y. That means I have to express x in terms of y. In the equation, y equals, our function is minus 3x plus 11. Now let us try to express x in terms of y. Now if I bring this to this side, we'll have 3x, then minus y plus 11, and dividing by 3, x will be negative 1 over 3y plus 11 over 3. That is what we call g of y. So in place of g of y, we replace negative 1 over 3y plus 11 over 3. So volume of revolution will be pi integral from a to b. A and b are given to be 2 and 8. Now g of y is minus 1 over 3y plus 11 over 3, the whole square, dy. Now, in order to solve this definite integral, it is better to use integration by substitution. So, for this, let us replace minus 1 over 3y plus 11 over 3 by y. Now, from this substitution, what will be du? Good. It is negative 1 over 3 dy. Or if you like, dy is negative 3 du. Now, from this substitution, when y equals to 2, what will be the value of u? U will be negative 1 over 3 y plus 11 over 3. So I'll have negative 1 over 3 times 2 plus 11 over 3. This is minus 2 over 3 plus 11 over 3, 9 over 3 that is 3. So I replace the lower limit of integration, that is 2 by 3. And when y equals 8, what will be the value of u? In the equation, u equals minus 1 over 3y plus 11 over 3. So minus 1 over 3, y is 8, plus 11 over 3, minus 8 over 3, plus 11 over 3. This is 3 over 3. 3 over 3 is 1. Therefore, the volume will be equal to pi times the integral from 2 to 8 will be replaced by from 3 to 1. From 3 to 1. It says minus 1 over 3y plus 11 over 3 is the whole square, but this expression is u. So u square. U square. It says times dy. dy is negative 3 du. Negative 3 du. Now let us take negative 3 out, so you'll have negative 3 pi integral from 3 to 1 of the integral of u square du. Negative 3 pi, the integral of u square is 1 over 3 u cube. Evaluate this from 3 to 1. Minus 3 pi times 3, obviously this is negative 1, so we have negative pi. 1 over 3 times negative 3 is negative 1, so negative pi times 1 cube minus 3 cube. Minus pi times 1 cube is 1, 3 cube is 27, minus pi times negative 26, and the product will be 26 pi. So this is the volume of the solid figure. Now let us see this answer. 26 pi. Good. That is 26 pi. Now let's pass to the fixed example. Find the volume of solid generated when the region bounded by the graph of y equals x squared plus 1 and the line y equals 4, this horizontal line, when it is rotated about the y-axis. Now, if you rotate this region about the y-axis, we'll have such kind of cup-like solid figure. Now, let us see how to find the volume of this solid. Now, volume of revolution about the y-axis is pi times integral from a to b of g of y, the whole square dy. But here we have given y to be equal to x squared plus 1, so let's express x in terms of y. So you'll have x squared equals y minus 1, and the value of x equals plus or minus of y minus 1. Now, we can take either the plus sign or the minus 1, because after revolving this region about the y-axis, we'll have such a solid figure, and if we revolve only this part of the region, that is found in the first quadrant, about the y-axis, we'll have the same solid figure. Therefore, we can take simply x to be equal to the square root of y minus 1, and we usually call it g of y. So volume will be pi times integral from a to b. From a to b, in our case, from 1 to 4. From 1 to 4 of g of y is the square root of y minus 1, the whole square, and then dy. Pi times integral from 1 to 4, the square of the square root of y minus 1 is y minus 1, so dy. Now, what is the integral of this one? It is half pi, half y squared minus y. Evaluate this from 1 to 4. So, pi there is half y square, 4 square minus 1 square, 4 square minus 1 square, minus y, 4 minus 1. So you'll have pi times, this is 16 minus 1, 15, 15 times 1 over 2, 15 over 2, minus 4 minus 1 is 3, so you'll have 3. Pi times 15 minus 15 over 2 minus 3, that is 15 minus 6, 9, 9 over 2 pi, or simply you can write it as 4.5 pi. So this is the volume of the required solid figure. Now let us see its answer. Good, that is 4.5 pi. Okay, let us pass to work the example 6. It says find the volume of water in a spherical bowl of radius 5 meter if its maximum depth is 2 meter. Here we have a spherical a spherical bowl of radius 5 meter, and within it there is water, and the maximum depth of the water is given to be 2 meter. Now the question is find the volume of the water within this bowl. Now first let us see how to generate this spherical bowl. Now if you take only quarter of the circle centered at 0, 0 and having radius 5 units, if you take only quarter of this circle, that means only this part of the circle, and if we revolve this about the y-axis, we'll have this spherical bowl. Okay? Now with the same token, to find the volume of the water, what we have to do is revolve the region that is bounded by quarter of this circle. Quarter of this circle can be found by the formula x square is 5 square, 25 minus y square, and x is plus or minus of the square root of 25 minus y square. But since I take only portion of the graph that is from the right of this vertical line, we'll have only plus of square root 25 minus y square, and we call it gy. Now if you revolve this quarter of a circle about the y-axis on the closed interval -5, -2, -3, because we have given that the maximum depth of the water is 2 units. Therefore, since this is -5, the top of the water will be at -3. So the volume of the water can be calculated by the formula integral from A to B of volume of revolution about the y-axis. G of y is the whole square dy. My g of y is this one. Pi integral from A to B, from -5 to -3. From -5 to -3. My g of y is a square root of 25 minus y square, and then the whole square dy. Now, what is the square of the square root of 25 minus y squared? Obviously, this is equal to simply 25 minus y squared. 25 minus y squared. And times dy. Now, what is the integral of this one? 25 minus y squared? Good. The integral of 25 minus y squared is 25y minus the integral of y squared, it is 1 over 3 y cubed. Now evaluate this from -5 to -3. So we have pi times 25 minus 3 minus -5. Minus 3 minus -5. Minus 1 over 3. Then negative 3 cube minus negative 5 cube. So we have pi times 25 negative 3 minus 5. It is plus 5. Then minus 1 over 3. The cube of negative 3 is negative 27 minus the cube of negative 5 is negative 125. That is pi times 25 times negative 3 plus 5, it is 2, minus 1 over 3, negative 27, minus, it becomes plus 125. So we have pi times, this is 50, minus 1 over 3, and minus 27 plus 125 is, I think, 98. So pi times 50 minus 98 over 3. Now let us subtract this one from 50. Now 3 times 50, 150. 150 minus 98 is, I think it is 52. 52 over 3. Therefore, the volume of that water will be 52 over 3 pi. Now let us see the answer in our slide. Yeah, it is 52 over 3 pi. Now this is the last worked example. Find the volume of the solid generated when the region bounded by the graph of x equals square root y and the y-axis between y equals 0 and y equals 4 about the y-axis. Now, again, volume of revolution about the y-axis is integral from a to b, pi times integral from a to b of f of y or g of y, the whole square dy. Pi times integral from a to b, in our case from 0 to 4, from 0 to 4. And g of y, it is already given as a square root of y. So a square root of y, the whole square dy, I think it is very easy. So I'll have pi times the integral from 0 to 4 of the square root of the square of the square root of y is y, dy, and that is the integral is half of y square. Evaluate this from 0 to 4, 1 over 2 pi. Now 4 square minus 0 square, 16 minus 0 is 16, and half of 16 is 8 pi. Therefore, the volume of the solid figure will be 8 pi cubic units. So by this, we have come to the end of our worked examples. After this, I think the answer is 8 pi. Good, that is 8 pi, we are correct. Now, I'll give you this exercise. It comprises about 5 questions. And 3 of the questions are finding volume of solid of revolution about the x-axis. And the next 2 questions are about finding volume of revolution about the y-axis. So try these questions, and after solving these questions, you are expected to write your answers in these answer sheets. Now for question number 1, I have given you 3 spaces. For question number 2, 3 spaces. And your answers are any of these numbers that I have given you in the box. Therefore, you can easily solve the problem and then relate your answer with the numbers that are given in the box. Okay, thank you very much. See you.